Hello guys, welcome on Tesla Adventures. In this video, we are going to discuss the second case of viscosity in which there is a disk which is kept on a viscous liquid of viscosity coefficient eta, and the thickness of the layer of the liquid is h. So we have given an initial velocity of omega naught to this disk, and we have to find out the velocity of disk, angular velocity of disk at any time t. So obviously we know that this layer of fluid will retard this disk, and it will apply some torque on the disk which will retard the disk. And to find out that torque, let us first of all imagine an element. So let us see that there is a small element which is a ring. So let us assume this as a ring, and this width of the ring is dx, and the radius of the ring is x. Okay, so we know that the periphery of the ring, if let's suppose at time t, this is the scenario at time t is equal to t. So at this time the angular velocity omega will be slightly less than omega naught, because at time will pass, the angular velocity will decrease, and the initial angular velocity was omega naught. So as we know that obviously each part of this disk, of this ring, elemental ring, will have a velocity v which is equal to x omega, and therefore a viscous force will be acting in the reverse direction like that on each element. So this viscous force dF will be equal to neta into area. Now area of this elemental ring will be 2 pi x dx into velocity gradient. Now velocity of this each part of this ring is x omega, and if we are writing down the gradient, then we have to divide it by h. So the velocity gradient will be x omega by h, and this force dF will be producing a retarding torque. So d tau will be equal to 2 pi neta into omega into, now torque will be force into displacement, force into distance from the center, which is x. So torque will be, this is x cube divided by h. So it would be 2 pi neta omega and x into x, because torque will be force into x. So this is x cube divided by h. Now the total torque will be the integration of this one. So it would be 2 pi neta into omega into x cube by h, and the limit would be from 0 to r. So the total torque will be equal to 2 pi neta omega by h, and this is x to the power 4 by 4, and the limit of x would be from 0 to r. So torque will be equal to pi neta omega by 2h into r to the power 4. This will be the total torque acting on the disk due to the viscous force, and this torque will be retarding the disk, and therefore this is a retarding torque. So we can equate this torque to I alpha to find out the angular retardation, and we know that the moment of inertia will be, for disk it would be m r square by 2 into alpha. So cancelling this 2 with 2, alpha will be equal to pi neta into omega into r square divided by mh. Okay, this is alpha, and this is angular retardation. So if we write down alpha as d omega by dt. So there should be a negative sign because it is angular retardation and it would be retarding down the angular velocity. So it is pi neta omega r square by mh. So it is pi neta omega r square by mh. Okay, and in this case d omega by omega will be equal to pi neta r square by mh and with a negative sign, and it is dt. The limit of omega will be from omega naught to omega, and limit of time will be from 0 to t. So it would be ln omega by omega naught, and it would be equal to pi neta r square by mh, and there is negative sign, and this is time. So omega will be equal to omega naught e to the power minus pi neta r square t by mh. Okay, so this will be the angular velocity at any time t, and if we draw a graph, then it would be an exponentially decaying graph like that, and it would take infinite amount of time for the disk to be in complete rest. Okay, so the heat generated, the total heat generated will be obviously equal to the total kinetic energy initially. Total kinetic energy initially, because eventually all the kinetic energy will be lost in the form of heat. So we can say that the heat generated will be the initial kinetic energy, which is half I omega naught square, and I is equal to m r square by 2 into omega naught square. So heat generated will be equal to m r square by 4 omega naught square. And now if this is the complete heat generated, now if we wish to find out the heat generated at any time t, or if we wish to find out the heat generated till any time t, so we can write down the power lost. So power lost can be written as torque into omega, and that retarding torque was this one. Yes, this torque was this one. So pi neta omega r to the power 4 by 2h. So it is pi neta omega r to the power 4 by 2h. This is the torque, and this is into omega also. So the power loss is pi neta omega square r to the power 4 by 2h, and this power lost is obviously heat loss, so this is dH by dt. We also know that omega is this one, so we can substitute the value of this omega into this equation, and we can integrate to find out the heat generated as a function of time. So I would not be going deep into that, but you can also attempt that part by yourself. So guys, this was it in this video, and in the next video I'll be bringing some more concepts related to viscosity. Thank you.